Today we will be solving uh, multiple choice questions for physics extended from Feb March 2023. So the first question is, which list contains two scalar quantities and two vector quantities? So scalar quantities are quantities which only have a magnitude meaning only value. So speed in this example would be a scalar quantity, because it only tells you how fast you are going, not where you are going. So vector quantities have magnitude plus a direction. So distance is scalar because we can only measure length. You can't tell the direction of length. You can measure the speed, but you can't tell where something is going. And for time, it is also a scalar quantity. We can only say what time it is, not where it is. So answer would be B, because B has force, as force can be written as force is equal to mass times acceleration. Now acceleration itself is a vector quantity. This arrow means this is a vector quantity. So force is also a vector quantity. Now velocity is change distance upon time. Velocity is also a vector quantity. Distance is a scalar quantity. Mass is also a scalar quantity. We write the unit for mass as kilograms. Next one is, the diagram shows the speed time graph for a car. So in this graph, first of all, there are 2 points marked X and Y. X is marked on the gradient and Y is marked on the constant value. So at Y, it is moving at constant speed because it will mark only one value at the speed graph, speed axis. But X is on the gradient. That means it is moving with changing speed. This is not constant speed. Constant speed is this Y value. This X is, it is changing with respect to time. So it will be C. No, moving with changing speed and moving with constant speed. So it can't be at rest. If it was to be at rest, then there would be no speed. It will be zero. But as this is speed versus time graph, this will be constant speed. It is B. Next is, 4 objects are moving in a straight line. The table shows the distance moved by each object in each second of its motion. Which object is moving with constant non-zero acceleration? So constant meaning it should be this. The increment should be a straight line. It should be linear or uniform, and it has to be non-zero. That means it can't be zero. It can be positive or negative, but it can't be zero. So the columns are distance moved in the first second in meter, distance moved in second in meter, respectively for third and fourth. Now the first column shows you, first row shows you 5, 5, 5, and 5. This means if I take there is no increment in speed. It is moving at the same speed and it is covering the same distance. That means there is no acceleration. It is constant speed. Next option is, it used to be 5 meter per second. Then it started to move at 6 meter. So it increased by 1. So this is 1. This is plus 1. So this is plus 1 acceleration. This is also plus 1 because then it moved from 6 to 7. So it is incrementing by positive values of 1. But now the next option is 5, 7, 10, and 14, and 5, 8, 14, and 26. They are also increasing in acceleration, but they are not constantly increasing. The first one is the difference is of 2. Second one is difference is of 3. Then the difference of 4. Same goes for this. The difference is of 3. Difference is of more than the before. So it has to be uniformly increasing. That means increment should be of same values. So the answer is B. Next is, the drag force on a car increases with speed. So if you, let's say, move at a greater speed, there will be more drag. That means the car will reach its maximum speed limit. At 20 meters per second, the total drag force is 400 newtons. So drag force, let's say it is D, is equal to 400 newtons. The mass of the car is 1200 kilograms and the driving force is constant at 700. So let's say this is the car. It is moving forward with a driving force of 700 newtons and the drag force is of 400 newtons. So the resultant force is 700 minus 400, which comes out to be about 300 newtons. So it is moving in the, in this diagram, in the right direction with a constant force of 300 newtons. Now next is, they have also given us the mass of the car. So we know formula is force equals mass times acceleration, and we want to find the acceleration. So it would be acceleration equals force upon mass. So it would be 300 divided by 1200, which comes out to be about 0.25 meters per second square. So acceleration is 0.25. So these are two options which are 0.25 in there. Now the next bit of information that they gave was the drag force increases when speed increases. So when speed is increasing, drag force also increases. That means the acceleration will decrease over time because the difference between the force and the drag force will decrease, and force is directly proportional to acceleration. So if resultant force decreases, acceleration will also decrease. The answer is A. Next is, a rectangular swimming pool is 50 meters long and 25 meters wide. It contains water at a depth of 2 meters. The density of water is 1000, and we want to find the mass. Okay. So first of all, we know density is mass upon volume, and volume itself is length into breadth into height. And we have been given the length, breadth, and height. So now mass will be equal to density into volume. So density into volume means it will be 1000 into these three values, 50, 25, and 2. So twice of 50 is 100. 100 times 1000 is 10,000, and 10,000 times 25 is 25. Okay, so I'll just multiply this by this. So 1000 times 50 times 25 times 2. It comes out to be 2.5 million. So it is about 2.5 million kilograms. Answer is D. Next question is, an object is rising vertically at constant speed through water. So it is rising through water at a constant speed. There are three vertical forces acting on it: the weight W, the drag force T, and the upward force U. Which diagram shows you magnitude and direction of the vertical forces acting on the object? Okay, so as it is moving with constant speed, that means there is no resultant force. So the upward forces should match the downward forces. So the first option tells you that the total forces acting on upside is 3 and downwards is 3. So first criteria is checked. That means it is moving at constant speed. Second one, 3 and 2. If you add them, you get 5. So this is not moving at constant speed. Next is 2 and 4. This is also not moving at constant speed. Next is 3 and 3. So this is moving at constant speed. But now we have been given that the object is rising vertically. That means there is only one force which is pushing it upwards, which we call as the buoyant force. But in this case, they have only given us the upward force or the upthrust force. So it will be acting upwards. So Upwards is done for both. But next is there is weight, because this ball also has a weight. So this weight will be acting downwards towards the center of earth. So in both the cases, weight is also downwards. But the next bit of information is the drag force D. So drag will happen in the opposite direction to the motion of the object. So it is trying to move upwards. So drag force should be downwards. So it is T. Upward force, the weight of the object, and the drag force, D. Seventh is two boys of equal weight sit on one side of a seesaw as shown. Their father of weight 1000 newtons, so his weight is 1000 newtons, sits on the other side. The seesaw is balanced and it is being used so that it moves up and down. During one part of the cycle, the father descends through a distance of 40 centimeters. At the same time, the boy nearest the pivot rises through 20 centimeters, while the other boy rises to 80 centimeters. And we want to find the weight of each object, each boy. So first of all, the formula is for clockwise movement, because we will try to push it downwards. It is descending, so this is anti-clockwise movement. So it will be, let's say, F into D, capital D, will be equal to the clockwise movement of due to these two boys. So it will be, let's say, F1, let's say W, weight W into D1, the first boy's distance from the pivot. We'll put this in bracket, plus the weight of the second boy, let's say W again, into D2. So the moment of force due to the father will be equal to the moment of force due to these two boys added. So now next is, we know force of father, weight of father is 1000. 1000 multiplied by the distance he moved was 40. So we will just multiply them. It will be equal to, now weight of the boys are, the beam is balanced. That means these two boys have the same weight. So we will take W as a common factor and then add D1 and D2, which is actually 20 and 80. So I will just multiply this. It will be 40,000 divided by 80 plus 20 is 100, which will be equal to the weight. So weight comes out to be equal to, the two zeros get cancelled from both the numerator and the denominator. So only 400 is left, and 400 Newton is the weight of each ball, because they are both equal in weight. So we will take the weight in denominator, as common factor. So we got W equal to 400, which will be the weight of each ball. Now, next is, a student measures the length of a spring. She then attaches different weights to the spring. She measures the length of the spring for each weight. The table shows her results. So this is the table for weight versus length. So when no weight is added, the length is 520 millimeters. What is the extension of spring with the weight of 3 newtons attached? So 3 newtons is here. And we want to find the extension. So now the length is 533. So originally, when no weight was added, the length of the spring was 520. It has now increased to 533 when 3 newtons of weight is added. So we'll just subtract 533 by 520, we get 13. So the answer is D. Now, the moment of a body is changed by a force acting on it for a period of time. Which action increases the change in moment? So we know force is equal to momentum times time. So we want to find the relation between force and time. So force is directly proportional to time. And if I want to increase the change in momentum, what I can do is, I can double the force, and I can leave the time as is. So if I double the force, there will be double the moment. Sorry, double the momentum. So the answer is B. If I do, let's say the first one, double the momentum half the time, then this 2 and 2 get cancelled. So I get the again the same momentum. So the momentum hasn't changed. For the C and D, halving the both the force and time. So if I halve both of them, the same as multiplying both the sides by 2, halving the time and doubling the force. So if I halve the force, and I double the time, so it is basically multiplied by F will be equal to 4 times the momentum times time. So I want to increase the change in momentum. So it depends on doubling the force for the same amount of time. Next is the equation used to find the change in gravitational potential energy of an object can be written as del EP is equal to y into z into del h. But del EP is the change in gravitational energy and del h is the change in height. So what is missing here? To find GPE. So GPE depends on the mass of the object, the height, and also the gravitational field strength or the acceleration due to gravity. So y can be either mass or gravitational field strength. So we have to have both of them present. So mass and gravitational field. So it doesn't depend on density because it doesn't care about volume. It only cares about the mass. The answer is A. Next is a machine has a power input of 200 watts and a useful output energy of 1 kilojoules in 6 minutes. What is the efficiency of the machine? So for efficiency, formula is, in short, it is power output divided by power input. And whatever I get, I will just multiply it by 100 to get it in percentage. So they have given me power input of 200 watts and the useful output energy of 1 kilojoules in 6 minutes. First of all, I will find the power output. So power output is equal to work done per unit time. So joules per second. So 1000 joules divided by, now 6 minutes in terms of seconds would be 60 times 6. I'll just multiply 6 by 60. So I will get 360. I will divide 1000 by 360. And I get 2.77. So let's round it off 2.8 watts. So now I have the input power and the output power. I will use the efficiency equation to find the efficiency. So it will be 200, which is the, sorry, output was 2.8 divided by 200, which comes out to be 0.014. Now, this is in just efficiency. So I will have to, if I want to know it in terms of percentage, because the unit is in percentage, I will just multiply this by 100. So I will shift 2 decimal places. So it will be 1.4, which is C. C is the answer for 11. 12th is, what is the unit of power? Now, as we just saw that power is energy per unit time, energy transferred per unit time. It is joule per second or watts. So answer is found in here, 200 watts. What is the unit for power? Or you can also use joule per second. Now, next question is, the diagram shows a rectangular block of weight 16 newtons. It is resting on a flat surface. What is the pressure at the base of the block due to its weight? So we want to find only the pressure at the base. So I will take these two values, the 4 and 5 centimeters. I'm not concerned with this 9 because that is the height of the object. And why am I not taking the length of the object into account? Is because pressure is equal to force per unit area. It only deals with the area on which the force is acting. So in this case, the area is the base, which is 4 times 5. So pressure will be equal to 4 times 5, which is, sorry, the weight is 16. So I will divide 16 by 20. 16 by 20. So it gives me 0.8 Newton per centimeter square. So the answer is C. Next is an oil tank has a base of area 2.5 centimeters, sorry, meter square, and is filled with oil to the depth of 1.2 meters. And the density of oil is given. What is the force exerted on the base of the tank due to the oil? Now, first of all, we will find pressure because pressure is force per unit area. So we know pressure is force per unit area. So I will arrange things for force. So force is equal to pressure into area, which is okay. So the equation for this would be okay. So we have been given a liquid. So the formula for pressure for liquid is P is equal to H, which is height, rho RHO, which is the density, and we will multiply that by the acceleration due to gravity, which is G. So depth is 1.2 into rho is 800 to G has to be taken as 9.8. Comes out to be 1.2 to 9,408. Comes out to be equal to 9,408 newtons. No, sorry, pascals. PA. So this is the value for pressure. Now I will use this pressure to calculate the force exerted. The pressure is equal to force per unit area. So I know how much pressure this oil is putting on the base of the tank. So I will arrange this for force. For force will be equal to pressure into area, which will be equal to 9,408 into area is 2.5, which gives me 23,520. So this number is newtons. So this number is very close to T. So the answer is D. So first of all, we calculated pressure using the formula for liquids, pressure in liquids, and then so the pressure came out to be, sorry, force came out to be 24 newtons. So first of all, we will find pressure using the pressure in liquids formula, which is H into density into the G, gravitational field strength. And using the pressure, we will use the formula now for force upon area, calculate force. So force is equal to pressure into area. So the pressure came out to be 9,408 pascals. We will multiply it by 2.5, so we get about 24 newtons. 24,000 meters. Now next question is, a sample of gas is trapped in a rigid container. If the temperature of gas is increased, the pressure increases. Now this statement is not correct. So you want to find the statement which is not correct. So temperature is increased, the pressure increases. And the sample is trapped in a rigid container. That means the volume is fixed. So the gas molecules have greater kinetic energy. If pressure has increased, that means the speed of the gas molecules have also increased. So their kinetic energy has also increased. So temperature, gases, and pressure, which is not correct. So this is a correct statement. Next is the gas molecules hit the walls of the container harder. So this is also correct statement. Gas molecules hit the walls more frequently. As speed is has increased, that means the number of collisions every second will also increase. Next is the gas molecules move further apart. Now volume is fixed. That means they can't move any more further apart than they are already. So the answer is D. This is not correct. If it was, let's say, trapped in a balloon or not non-rigid container, then this will also be correct. What happens when the temperature of a liquid increases? So when temperature of liquid increases, its volume also increases. The mass doesn't change. The amount of substance doesn't change unless it has boiled off or something. The mass doesn't change. But in this case, the volume increases. And if volume increases, the density of the liquid decreases because density is mass upon volume. So if volume increases, density will decrease, so making the liquid less dense. So answer is C. Next is, a bar of metal, which is a good thermal conductor, is heated at one end. What is the main method of transfer of thermal energy along the bar? Now, as it is metal, it has two forms of energy transfer. One could be lattice vibration, in which the lattice vibrates. The lattice is basically arrangement of atoms. So the arrangement of atoms themselves will vibrate and pass on the energy to adjacent atoms. But that will take a longer time because it will have to and transfer energy to each and every atom. But the main method of transfer of thermal energy in metals is due to the transfer of electrons. As metals have delocalized free electrons, delocalized meaning they are not bound to any atom. They can move from the hotter region to the colder region and transfer that energy while traveling. So it is done by, main method is transfer by electrons. Next is, a transverse wave moves along a rope. This is a transverse wave. The diagram shows the position of rope at one particular time. Which two level points are one wavelength apart? So as is, this is a transverse wave. It is displacement versus time or distance versus time. So to find the wavelength, we have to find the distance between two adjacent crests or two adjacent troughs, or just start of one wave and end of the other wave. So let's say this is start of one wave x, so one wave, and this is the end of that wave. So x and z are the x or z are one wavelength. Next question is, light in transparent plastic meets the boundary with air. Light is transmitted into air only if angle marked theta in the diagram is greater than 36 degree. So what is the refractive index of plastic? So light is transmitted into air only when angle marked is greater than 36 degree. First of all, what is the angle with respect to normal? Because we are only concerned with normal. So this is the normal, and what will be the angle? So if I draw normal with the surface, it is 90 degrees. So this whole angle is 90, and out of that we have made the angle with the surface of 36. So 90 minus 36 comes out to be 54. So 54 degrees is the angle it makes with the normal. Now the formula for refractive index using this angle is n is equal to 1 divided by sine of c, critical angle. Now how did I know it is critical angle? Because The statement says light is transmitted into air only when angle marked is greater than 36 degrees. So when this angle increases, the critical angle decreases. So if the light can only totally internally reflect when the critical angle of incidence is greater than critical angle. In this one, it is decreasing because this other angle is increasing. If this angle is increasing, that means this angle will decrease. So it will now change its it will now try to transmit into the air. So we will use the equation for critical angle. Now I will arrange it for C. So C will be equal to sine. So C will be equal to so sine inverse of in bracket 1 divided by n. So but we don't need this because we have the angle. So angle is 54. So n will be equal to 1 divided by sine of 54. So we know n is equal to 1 upon sine c. So c will be equal to sine inverse of 1 divided by n. So sine inverse of, sorry, we don't need to do this. We just have to use n is equal to 1 divided by sine c form because c is already given. So n will be equal to 1 divided by sine of 54. It comes out to be 1 divided by 0.809. So let's say 81. So 1 divided by 0.81 gives me 1.234. So closest answer is C. So the answer for 19th question is C. 1.2 is the refractive index. Next question is a thin converging lens has a focal length f. An object O is placed to the left of the lens. This is the object as shown. Where is the image formed and how does its size compare to the object? Now, the focal length is from here to here. That means this object is placed between the focal length and the lens distance. It is placed between the focal length and the lens. That means it will form an uh, magnified image. So the rays will never meet basically on the right side of the lens. So this is the parallel ray. It will go through the focal point. Next is the one that will go through the center. So these two rays are never meeting. So it will meet, let's say, somewhere behind, let's say here. So the image will be formed before, let's say, the focal point, and it will be enlarged. So it is on the same side of the lens and it is larger than the object. So it is now magnified. So the answer is C. Next is which diagram shows what happens when a ray of white light passes through a prism. Now, prism splits the lights into its constituent bands of light. So white light, when it enters, it then starts to spread apart. So it can't be A because in this one it is saying that when the white light enters the prism, it is still white light, and when it exits, that's when the spectrum is seen. But it happens inside the prism. But this so in this one, B is not right answer because this means that white light is going faster when it inside the prism, which is not possible. And in C, this means when it leaves the prism, it is fastest. This is also not possible. So when it enters it at a speed, it also exits at the same speed. So the answer is D because when white light enters, it spreads into its constituent spectrum band, and then it leaves with the same amount of speed. So the answer is D. Next is a television station transmits a signal to a television receiving dish. The television has an on-off indicator light, which is this one. Light is switched on by a remote control, which changes the indicator light from red to green. Which electromagnetic wave used in this actions has the longest wavelength? So the longest wavelength will have the least amount of energy, and as it is longest, that means it can travel more. So it is this A. It has to go from TV station to the satellite, then from satellite to receiving dish. So A has the longest wavelength. Remote control has infrared, which is longer than red light, which is this red and green, but it is not longer than the microwaves, which is my radio waves, which the satellites use. So it is A. Next is a student makes a list of some applications of waves. One is medical scanning of soft tissue, sterilizing water using sonar to calculate ocean depths. So which applications use ultrasound waves? So ultrasounds are sounds which are beyond 20,000 kilohertz. So we can't hear after 20,000 kilohertz. So those sounds are called ultrasounds. So we know sonars, the sonar word itself means using sound to calculate the depth. So ships and submarines are fitted with some sonar, ultrasound devices which can measure the depth. Next is sterilizing water. To sterilize water, we have to first kill the bacteria, which ultrasound can't do. So next is medical scanning of soft tissue. So we have ultrasound to scan soft tissues. So that is called so when let's say you go to doctor, so if you want to know what's happening inside your stomach, then you can use ultrasound sonography. So 1 and 3 are the only options which use ultrasound. Second one has to rely on other methods. So it is C. Next is the diagram shows a bar magnet that rests on a smooth horizontal surface. A length of soft iron wire is held parallel to the magnet. It is parallel to the magnet. The wire is now released. Now what happens? Now, first of all, as this is soft iron, it will get magnetized. So we know lines start from north and end to south. This is the arrow. So it will also go through this soft iron and then go back to south. So when north enters the soft iron, it will make this the south pole, and this will now make the north pole. As this is south and this is north, it will feel equal amount of attraction towards the both poles. So it won't rotate, but it will move towards the magnet. So the answer is just it moves towards the magnet. B. It doesn't rotate. And it won't move away because this is not a magnet. If this was magnet, then you can say that it might move depending on which pole is facing the magnet. But it will then again arrange itself so that it is in line with the north and south poles. Which diagram shows the electric field pattern and direction around a positive point charge. So this is a positive point charge, not a magnet. So the plus signs means these are positively point charge. So normally this would be the magnetic field, but we have been asked the electric field. So electric field starts from positive and end at negative, just like north poles of magnet. Starts from north and ends at south. In positive point charges, it will start from positive and end at negative. So the answer is A. Next is a laboratory has a standard wire of known resistance. It also has other wires made from the same material as the standard one, but of different lengths and diameters. Which wire would definitely have a resistance of less than standard wire? So we want a wire whose resistance is less than the standard wire, but it has to be made of the same material. So if you want to have least resistance, then the length of wire should be shorter and the diameter should be larger. So the answer is C. Next is the graph shows the relationship between the current in a circuit component and the potential difference PD across it. The graph has a straight section and a curved section. So I'll just point out where the straight section is. So till there, this is the straight section, let's say, and then it starts to curve. What happens to the resistance of the component in these two sections? So in this one, it is constant. However, amount the current is increasing, it's the same amount with the PD is increasing. So if you find the ratio of these two, we will get that resistance is not changing. But after this, potential difference is increasing, but current is slightly decreasing. And we know resistance is voltage upon current. So if current is decreasing slight bit, resistance will increase with the same number. So it is in the first section, it is obeying Ohm's law. So there is no change in resistance. But after that, resistance is increasing. So the answer is D. So when current decreases, resistance increases. So answer is D. Next is the diagram shows a part of a circuit. What is a combined resistance? First of all, there are two formulas to find combined resistance. One is for normal when we arrange resistance in series. So it is in this case 2 plus 4 because they are in series. So you can just add the resistance, which comes out to be 6 ohms. Now, this 6 ohms is parallel to this 4 ohms. That means we can replace these two resistance with a resistor of 6 ohms, but it will be parallel with the 4 ohms. Now, formula for parallel resistor is 1 upon R is equal to 1 divided by R1. So in this case, R1 is now 6 plus 1 divided by 4, which is R2, which will be equal to 1 divided by R is equal to, now 1 divided by 6 is 0.166. So let's say 0.17 plus 1 divided by 4. So quarter is 0.25. I will just add these two numbers. I get 0.42. Now, as this is 1 upon R, so I will just find the reciprocal of 0.42. So R will now be equal to 0.42, sorry, 1 divided by 0.42. Comes out to be about 2.38. There is some problem in calculation. Okay. So I use wrong value here. So it is 2 plus 1. So it is 3. So this will be 1 divided by 3. So this number will also change. This is 0.333 recurrent. Let's say it is a 0.33 plus 0.25. So about 0.59. So R will be equal to 1 divided by 0.59 or 0.6. So it will be 1.666. So it is recurring. So we just say it is about 1.7, which is C. Next one is the diagram shows a circuit which includes two resistors and a battery. These are the two resistors and this is the battery. The volt rate meter shows 6 volts. What is the potential difference across 30 ohms? So firstly, we will find the current in this circuit. So current in this circuit is given by I is equal to V divided by R. So through this resistor, we can find how much current is going. So it will be 6 divided by 10. Comes out to be 0.6 amps. So I is equal to 6 divided by 10 or 0.6 amps. Next is now the current flowing through this resistor is 0.6, but as it is in series with the 30 ohm, that means 0.6 is also going through this 30 ohm resistor. So the current through this 30 ohm resistor is 0.6. Now I will use the same equation. Now instead of finding current, I will find voltage. So voltage is equal to IR, which will be equal to 0.6 multiplied by 30. Comes out to be 18 volts. So the potential difference across the 30 ohms is 18. So the answer is C. Next is a wire is moved down in a direction perpendicular to the magnetic field. This is the magnetic field and this wire is made to go downwards. That's the arrow. Three changes are suggested. The chase speed of the movement of wire is increased. Magnetic field strength is decreased. The direction of magnetic field is reversed. Which change increases the electromotive force induced in the wire? Now EMF is induced when it is cutting the magnetic field lines and it has to be perpendicular. Now it is moving perpendicular with respect to magnetic field, that means EMF will be induced. And to increase the EMF, what I can do is I can increase the speed of the movement of wire. Next could be so if I decrease the magnetic field strength, that means the EMF will decrease, so we can't do that. And direction of magnetic field reverse. So if I reverse the magnetic field, the only thing that will change is the direction of current and not the amount of current. So the EMF induced, if I want to increase, then I can increase the speed. So answer is B. Next is a wire is moved across a magnetic field. This causes an induced current in the wire. The induced current interacts with the magnetic field to produce a force on the wire. In which direction is the force? No. The wire is moved across a magnetic field. Let's say we will use the example for this. Wire is moved across a magnetic field, perpendicular, let's do magnetic field. This causes an induced current in the wire. The induced current interacts with the magnetic field to produce a force on the wire. Now, induced current is trying to oppose the force acting on the wire. So let's say if wire is going downwards, the induced current will try to oppose it by making it move upwards. So the direction of force is opposite to the direction of wire, movement of wire, because it wants to oppose the change in its EMF. So the answer is D. So if let's say I will push this wire downwards, if current in the wire will try to push it upwards. Next is 100% efficient step down transformer has primary voltage VP and primary current IP, which row compares the secondary voltage VP and the secondary current with IP. So it is 100% efficient. That means there is no power loss. And the formula for power linking the primary coil and secondary coil is IP VP is equal to IS PS. Primary voltage, primary current is equal to secondary voltage, secondary current, because primary power will be equal to secondary power because it is 100% efficient. So if let's say now secondary voltage is greater, if it is greater than VP, then the current through it has to decrease because they are both directly proportional, and I want to keep the power same on both sides. So if I increase the voltage, then I will have to decrease the current. So the answer is B. Now, as it is stepped down, the secondary voltage has to decrease. So let's say it is receiving 400,000 volts. It will now decrease it to 230. That means the voltage has decreased, but to do that, we have to increase the current. So answer is C. The next is the scattering of alpha particles by a thin metal foil supports the nuclear model of an atom. What they have asked is why are alpha particles used rather than neutrons? Now, nuclear model of atom is there is a center of of an atom that we call as nucleus, and it is positively charged. So if I use a neutron, it won't interact with the charge of the proton. So we, instead of that, we will use a we are using alpha particles because it also has a positive charge. So this positive charge will interact with the positive charge in the atom, which was theorized, and it did, and that's why we could see a deflection. That's why we can say that the center of the nucleus is positively charged, because we used a positive charge alpha particle and they both deflected. They both started to repel each other. So answer is D. Next is an ion nuclide is represented by the symbol shown Fe. This is the nucleon number. Nucleon number means the number of protons plus number of neutrons, and 26. 26 is the proton number. So this is 26 plus something. So it is about 30 neutrons. 26 plus 30 gives you 56. Which statements about a nucleus of this ion nuclide are correct? First is the nucleus contains 56 neutrons. That is not possible because this is the nucleon number. This is the total of neutrons and protons. Nucleon number is 30. We can clearly say it is 56. Proton number is 26. Yes, proton number is 26. So the answer is 3 only. That is D. Next is a sample of radioactive isotope has a initial rate of emission of 128 counts per minute and a half-life of 4 days. So it started with 128 counts per minute and the half-life of it is 4 days. How long will it take for rate of emission to fall to 32? So I will just divide these two numbers, 128 by 32. I get 4 days. So answer is 35B. Okay, so half-life is 4. The difference is of 4. So 4 plus 4 is 8. Okay. So how will you calculate it? Let's say initial is 128. Half of that will be 64. Now I want to go to 32. So I will just again divide it by half. So it will now give me 32. 32. So first half life was, this was 64, second half life is 32. So first half life is of 4 days, second is also for 4 days. So 4 plus 4 is 8. The answer is C. Next is several scientists are working in a laboratory. The scientists are experimenting with sources which emit ionizing radiation. Each scientist is given a list of safety rules. 3 of the rules are shown. Keep at least 2 meters away from other people. Do not stay longer than 4 hours per day in the laboratory. Stay behind the lead line screen. Which safety rules are for protection against the effects of ionizing radiation? So, ionizing radiation means alpha particles and beta particles. First of all, definitely stay behind lead lines. Keep at least 2 meters away from other people. So this is not uh, a precaution because gamma rays can go more than 2 meters. So this is not possible. So do not stay longer. So if you keep your exposure to less than, let's say, 4 hours, so it will decrease your chance of ionizing radiation going through your body. So 2 and 3. So answer is D. That is evidences which data is needed to calculate the average orbital speed of a satellite around a planet. Now the orbital speed of planet is given by v, which is the speed, which is equal to 2 pi r. 2 pi r divided by the time period, orbit time. So we want to find, then r is the orbital radius. So distance of satellite from the center of planet, the radius of the planet. We don't want the radius of the planet, period of rotation of the planet. No, time for the satellite to orbit the planet. Okay, so we need these two values: the distance of the satellite from the center and the time it takes to orbit once. So our Earth takes 365 days. So that will be, let's say, T, and the distance from our Earth to Sun is some value. So we will just multiply by 2 pi, then you will get the orbital speed. So we only need distance and time. The only option is B. So 38 is approximately how long does it take for the moon to make one complete orbit of the Earth? Now we know we measure month by looking at the phases of the moon. So when we see the same phase of the moon, that means 1 month has passed. So that means we say that moon takes about 1 month to orbit our Earth. So the answer is B. But we see moon every day because our Earth is also rotating about its own axis. That's why the actual orbit of moon is 1 month, but we can see moon every night. Next is the energy generated in stable stars comes from nuclear reactions. Which type of reaction occurs in the sun? So energy generated in stable stars is due to reaction which is fusion, nuclear fusion. Fusion happens when you combine lighter objects to get heavier elements. So in this case, hydrogen is being fused or joined together to form helium nuclei. So when you combine, let's say, two hydrogen, you get a helium. So it is D. But it is not normal hydrogen, it is deuterium or tritium or any other. There are only two isotopes of hydrogen which have neutrons in them. So we can't fuse normal hydrogen to get helium. We'll have to use isotope of hydrogen. Next is two quantities define the Hubble constant h. The speed at which the galaxy is moving away from the Earth v and the distance of galaxy from the Earth, which is d. What is the relationship between v and d, and what is the current estimate for h naught? Now h naught is the Hubble constant. So relationship between v and d is it is the speed at which it is going away from us is directly proportional to the distance. So v and d is directly proportional, and the current estimate is about 2.2 into 10 to the power minus 8. This is the speed of light, so it doesn't make any sense. So 2.2 into 10 to the power. The speed of galaxies moving away from Earth is directly proportional to the distance from Earth, and the current estimate is 2.2 into 10 to the power minus 18 per second. So the answer for 40 is A. So that's all for this MCQ. I think you understood the answers. Thank you.